There's no whiteboard markers again. I can get away with no whiteboard. Give me just a second to start. So this is the moment in the lecture where I was going to dramatically write some stuff on the whiteboard. Since there's no whiteboard markers, it'll be slightly less dramatic. Okay. Should have written it down. What are some more buzzwords, acronyms, ideas that you could think of that relate to manufacturing today or in the future? CAD, CAM, CNC, PLC, IoT, AI. What else you got? What else talks to you about the future? Anything? Nothing? You guys should have one. Your group should have one. EDM. What else? What else you got? Lean. What else we got? What else? Anything else? Talks about the future. What? Can we just do 3D print? I know you're trying to say it fancy like and all that. 3D printing. Right. And so in there you got all the like SLA, laser centered. What's the laser centered? What's that? Yeah, there's all kinds of these things. So I say today I'm going to talk about the future of manufacturing. By the way, is any of the groups ready to give their presentation today? Because the syllabus said that we were going to do presentations today and on Thursday. So I wanted to make sure everybody had plenty of time to do their presentation. So if there is a group that wants to go today, we can do that at the end. Anybody ready? Okay, just checking. I didn't think anybody was ready, so I said I had to come up with a lecture topic. And as we're sort of at the end of this class, I thought it was appropriate to talk about the future. Is that careful? That sound good? And so I've been teaching manufacturing for 18 years now. I've been doing this job, teaching this class, ME 1800, ME 4815, for 18 years, almost 20 years. I like to say 20 years, but I've been saying that for about 5 years. So I guess it seems that time adds together. When this was not the thing that I thought I was going to do with my life. Who thinks they've got a plan for their life? Anybody? I had a plan. What's your plan? Ish. Broad strokes. Big brush. Work for an engineering firm. Make some money. Retire and do whatever the hell I want. You should start with retire and do whatever the hell I want. It's way more fun to do what the hell you want when you're younger. And that's kind of how I ended up here. So I was a WPI student. You guys know that? So I finished WPI on the 6-year plan in 1995 and promptly lost 5 jobs in 2.5 years. I determined that I was unemployable and declared myself retired. And it turns out that retirement has nothing to do with money and everything to do with state of mind, as long as there's enough money. And in my case, I had, when I was doing those 2.5 years, 5 jobs, I had invested in some rental real estate. Real estate investing is just math, and the math is not very hard. And I was good at not very hard math. So I was able to do that, and I was kind of bored. I called it tuna fish retired. As long as I only wanted tuna fish sandwiches, I was retired, didn't need any more money. If I wanted more than tuna fish sandwiches, I was going to have to do some consulting, do some extra work, do something else. But I was bored, 27 years old, came back to WPI to go to grad school. I wanted to go to actually electrical engineering. I was going to become one of these wireless networking gurus, because this was when wireless networking was just starting. And they laughed at me when I applied for the master's degree position. They said, well, your background is mechanical engineering. I said, yes, I know that. I said, what, you can't study electrical engineering at the graduate level unless you take 8 undergraduate courses in electrical engineering or go to UMass. They'll accept you. It was exactly what the guy said to me, the head of the graduate committee. And I was kind of pissed. I was walking back across campus. I stopped in to see my my old MQP advisor, and he at the time was the director of manufacturing at WPI. And I told him my woes, and he looked at me and he says, well, you could still take all those classes if you do a degree in manufacturing engineering, because somebody has to make that stuff. And I thought, oh, that'd be kind of cool. He said, and I've got some TA credits to give away. And like I said, I'm good at math. Free tuition, good price. So I became a manufacturing engineering graduate student with the intent of studying electrical engineering, just get my degree to say manufacturing engineering because I could do that for free. Pretty excited. I'm sitting in a seminar. They had required seminars. You guys have required seminars? Anybody? Yeah. There's required seminars when you go to grad school. They have like attendance list they pass around. It's very like third grade in demanding attendance. But anyway, so I'm sitting in this seminar. It was over at Higgins, second floor, the big room there. Some guy's talking about something. I couldn't tell you what he was talking about, but he said something that triggered a thought in my mind. It's sort of the, who's had an epiphany before? Anybody? So my epiphany was that no shit, manufacturing makes everything. Everything, it seems obvious, right? But if you don't think about it, you don't notice it. And so I was like, wait a minute, I should really study this manufacturing thing because it makes everything that makes the world happen. It makes everything that makes society happen. And so I started studying. Well, I mean, I was in the manufacturing program. I started actually caring about the manufacturing part of the manufacturing program, and looking at the manufacturing processes, what makes companies because manufacturing is about making stuff that people want, right? Manufacturing is about making stuff that people want. You know they want it because they buy it from you. So manufacturing is like a business thing, which was cool for me because I was kind of a business person when I got into it anyway. So I'm really excited about manufacturing and doing it well. And WPI got some new CNC machine tools. And I'd never really done much manufacturing or CNC machining. I was more thinking at that high level before we got these new CNC machine tools back in 2001. And they were cool. They were fancy. They were shiny. That was all exciting. My advisor was the guy that was responsible for bringing them in. So I had to be involved because you kind of do what your advisor wants you to do when you're a grad student. You'll find that out if you decide to go to grad school. So I had to be involved in the CNC machining stuff, even though it wasn't really lined up with my research. And there was some extra training slots available for WPI people to go get trained on how to use them. So I was like, well, I'll go. What the hell? And so I'm sitting there in the class. And we talked at the beginning of the term a little bit about G-code, right? I think I did a lecture where I told you there's 3 ways CNC machine tools move. And we went through 3-4 days of getting a blueprint, like a paper blueprint, doing the math to figure out where all the corners and the lines and the radiuses on the arcs and stuff, where everything was, where the center of the tool had to be in order to make that tool path, with all the trig and everything, and writing out G-code manually. And I remember second day of that class sitting there thinking, I am gonna be so rich because I could write a computer program that could do all this stuff. Like, there's no reason for me, the engineer, to be doing all this simple math because it's simple math, and it's like I said, I'm good at simple math, and I actually was pretty good at writing computer code at the time too. So, because the guy that taught the class did not mention the existence of CAM software, so we knew about CAD. Right, because we were drawing the drawings. We had CAD. He didn't mention the existence of CAM software. Well, it turns out I wasn't the first person to think of it. Back in the 80s, people had thought of it, and they started developing CAM software. I think Esprit came out in 1983, for example. So people have been doing CAM software for a while. So yeah, I wasn't going to be so rich because of that. But this whole idea of the CNC machining I got sucked into it. And I realized that CNC machining is the most prolific manufacturing process in the world. And so I say this, so there's lots of manufacturing processes out there, right? There's smelting, and there's painting, and there's thousands, probably tens of thousands of manufacturing processes that we could name if we set out to list processes. None of them happen today without CNC machining being there to assist them. CNC machines are used to make the tools that do the other processes. They're used to make the parts that go into the other processes. I would argue that you can't find a manufactured good that is more than 2 steps in its manufacturing process away from a CNC machine tool. So most prolific manufacturing process, we have access to great tools here. And so I became an expert at CNC machining and programming CNC machine tools and setting up CNC machine tools because I thought it was cool and because I could and because it was free. And actually I was getting paid to learn it. So it was pretty cool stuff. But I said today we're going to talk about the future of manufacturing. That's all past, right? So what when I say advanced manufacturing or the future of manufacturing, what are some things that come to mind for you guys? Anybody? If you hear advanced manufacturing, what do you think of? Automation. Okay, and so we talked about automation in the class too, right? And PLCs and robots, automation systems, all these things. So, all right, so automation you think is advanced manufacturing. What else is advanced manufacturing that somebody can think of? Yep. So 3D printing, this additive manufacturing, this building up something from nothing, right? Now, is 3D printing the first additive manufacturing process we can think of? I think it is the one that made us all switch to calling it additive and subtractive manufacturing. It was sort of the trigger. But is it really the first additive manufacturing process you could think of? No, what else? You shook your head no.
No, I mean,
you were just trying to like.
No, just like additive manufacturing. I forgot what it is. It like a powder metallurgy?
So powdered metal. So you take some powdered metals, you put them in a mold, you heat it up, you squish them together, and so you can make stuff using powdered metallurgy, powdered metal stuff. PM, they call them PM parts, powdered metal parts. And so it's kind of additive. You're putting stuff together, right? I mean, casting is kind of additive, right? You have a void, you add material to it, and it solidifies. Casting is sort of a kind of it. Welding is additive manufacturing. Right? So we've been doing additive manufacturing for a long time. I mean, building a house is kind of additive manufacturing. We might cut up some 2x4s to subtract some length. When we stick them all together, we're manufacturing that house. We're putting it together. So we've been doing additive manufacturing for a long time. What was your first experience with 3D printing? First time you knew that it was a thing?
I think like sophomore year of high school, there was like an optional like after school thing where kids could go and invest in 3D printers.
So all right, so your sophomore year in high school, there was a thing you could go mess with 3D printers. Anybody else? First experience, first time you knew 3D printing existed?
Freshman year of high school.
Freshman year of high school, similar thing?
Yeah.
What do you got? Okay. That's cool. So high school also? Freshman year of high school? Oh, so you actually did an internship at a company that was doing 3D printing or building it? Oh, kids program. Yeah, cool. So everybody in the classroom heard about 3D printing in high school, pretty much. What years were you guys in high school-ish? When did you graduate? 2019? 2020? Oh, I should know when you graduated. Ish. Within 4 years, I should know when you graduated, right? Okay. So I first ran into 3D printing after college. I was working as one of those 5 jobs. It was the 4th of the 5 jobs. I was working at a company in Manchester, New Hampshire, and we were going to be the Coca-Cola of our industry. I don't know why we picked Coca-Cola, but we wanted to be very prolific in the industry. And we were developing this new product. It was going to be the best ever built, and we had to know what it was going to look like because it was a consumer product. And so we had this 3D printed shell of the outside of the product made for us. This other company that was down somewhere between Manchester and the border, down one of the highways that went south there. I can't remember where it was exactly. I do remember that I was the one that had to go pick up the stuff there and drop off stuff there because I was the one that lived in that direction. So I always had to go drive down there. And I think it was like $10,000-$15,000 for one box. It was about this big, about yay big, black. Black was the only color you could get. And that was like so cool, except don't drop it because it'll shatter. Right? It was amazing. It was great that we could see if the parts were going to fit. And so instead of 3D printing, we could also do computer modeling, right? For stuff like that. But it was nice to have something you could set it on the desk. It was great for the CEO to have it sitting on his desk. It was kind of a cool company because I actually shared a cubicle space with the CEO of the company. So that was kind of cool as a young engineer being there. We listened to the guy on the phone calls, making wheel and dealing stuff. We had some kind of computer component that needed to go on one of the boards in the thing. And we could find in a catalog a product that had that same component in it for cheaper than we could buy the component. And so he just happened to know the guy that published the catalog. So he called him up and found out where he bought those things and found out where those people bought it. And we got that thing cheaper. So it's kind of cool to hear that stuff. But anyway, so we think of things like 3D printing as the future. We think of automation as the future. And I would say there's going to be a lot of 3D printing in the future. I think right now where the technology is, the 3D printing is really good at making near net shaped parts. And near net shaped parts are really good because then we don't waste as much energy and time and material doing the finished machining that make the parts what we want. We're still going to do that CNC machining at that step. What are the most important skills for engineers going into the industry today? Fast learning. Okay, so you like fast learning because the technology is always changing. Okay, technology is changing. I like fast learning. Communicating effectively. We're gonna find out how good you are at that on Thursday, right? Some of you. Okay, effective communication, fast learning. What else? Is CNC programming important? Somebody's got to do it. I'd say that for the next 30 to 50 years, it's going to remain the most prolific manufacturing process. What do you think? Some amount of what kind of experience? Coding, right? Coding and programming. I spent the weekend refreshing my knowledge of JavaScript, right? So some amount of programming is going to be important to people moving forward. Good friend of mine, he writes software. He works for a company that writes software for banks. Specifically, one of the things that they do is they make the customized interface for your personal banking software if you happen to have a last name like Kennedy. So if you're, or Gates, like if you're Bill Gates, when you log into your bank, you get custom software. It turns out you don't have to just deal with whatever the bank has. So they write custom software. And this guy is he's actually the security expert at this company that does all this custom banking software. He's got a PhD in physics, right? So the thing that you study isn't necessarily the thing that you're going to end up doing. Most people that study mechanical engineering, specifically mechanical engineering design, they have a dream that they want to go design race cars or airplanes, things like that. A lot of people. I know that was my sort of dream moving into that field, was to be able to design things Well, it turns out all those things have to be made. Most engineering goes into making them, not in designing them. I mean, there's a lot of engineering that goes into designing them, but most engineers actually work in the making side of the business. So I'll let you know the skills that I think are going to be important and why they're going to be important. So you said fast learning. And I think that's a skill that everybody needs all the time, especially with the rapid pace of changing technology. But change is the only thing that's inevitable, right? The only thing we know for sure is that it won't be like this tomorrow. In fact, tomorrow it'll be a snowstorm, right? That's what I love about New England. If you don't like the weather, wait a minute. So that fast learning, that's important for every career field, I think. You said effective communication. And that also, I think, is important for every career field. I think it's especially important that we emphasize it with engineering students because we don't talk real loud to lots of people usually, right? You can tell the extroverted engineer because they look at your shoes when they talk to you, right? You've heard that. So I think it is especially important that we, as engineers and engineering students, develop our speaking skills. And there's places where you can do that. There's clubs. There's what's the one where they get up and speak and they do speeches? What's the name of that club? I'll Google it later. I'll tell you. But there's ways to get really good at public speaking, and I suggest everybody get out of their comfort zone and be able to do that. When I decided that, when I took this job teaching, it was to see if I wanted to be able to, if I'd like teaching. I had no idea if I liked teaching. In fact, it said on my cover letter that I can do the job and I'll do it while you look for somebody. And that was back in 2006 for this particular job. So I don't think they've been looking that hard. But when I found out that I liked teaching, I wanted to get good at it because it sucks to like something and be doing that something and not be any good at it. And so I started studying teaching. And the people that write about teaching, they're too stuck on themselves. I don't like to read their stuff. So I started studying learning. And the people that write about learning, they actually care about the students because they're studying the learning, not the teaching. So there's two different steps, right? There's teaching, that's me teaching you. And there's learning, that's you actually receiving something. And I quickly came to the conclusion that I can't teach anybody anything. But if I try hard enough, I can perhaps inspire some people to want to learn some stuff and provide them with some resources that help them learn. So I quickly learned that. And how do you inspire people to want something? So then I started studying marketing because that's all marketing is, right? It's trying to get you to make a decision to buy something. So I could get you to make a decision to learn something. And for marketing, I quickly went to brainwashing because that's just the ultimate in marketing. And so when I wanted to do this, so I don't think you need to go quite all the way to marketing, sales, brainwashing in your journey to be better public speakers. But I do think that you need to consider learning a little bit about selling and learning a little bit about marketing because your job as an engineer is going to be easier if you can sell your ideas to your supervisors, to your colleagues, to your coworkers. So I do recommend studying some of that stuff. And I think that will make, again, anybody in any career, it'll make them a better person. Let's focus on manufacturing, the skills that are going to be important. So who does the most manufacturing? Who does most of the manufacturing in the world? So if it's skills that are going to be important in manufacturing, we should get skills that are important to the people that do most of the manufacturing. And so in the United States, most manufacturing happens at small businesses. 70% of all manufacturing in the United States happens at businesses with less than 50 employees. So in the United States, we need skills that are going to help small businesses succeed if we're going to do well, if we're going to have skills that help manufacturing succeed in the United States. So those are the kind of skills that we are really good at developing here at WPI. So these teamwork skills, right? So the group projects and the learning how to get along with your group, right? Because in small businesses, it's like one long continuous group project. And there's going to be people that every group project experience I have ever had as part of the group, there was always people that sometimes you felt they weren't pulling their weight. There was always people that sometimes were doing more than everybody else. There was always people that already knew the answer and wouldn't listen to any discussion about what the answer might actually be, right? And so being able to navigate those situations, I think WPI is really great at preparing us for that part of working at a small business. Now, these small businesses, this is something you probably don't know, because we've talked about the fact that most of them are small businesses. Something you probably don't know is most of those small businesses are owned by people that are between 67 and 72 years old. I was on the phone with a guy on Friday. He's 81 years old. He's got 32 employees. He just bought a $300,000 machine tool to add to his shop. He's growing his business. He's 81 years old. One of my best friends is 80 he'll be 81 this year. And he calls me a couple times a week with startup ideas because he already sold his business. So now he's just got ideas, right? But that's kind of a bad sign that most of these businesses are owned by people that are retirement age. And there's two things, well, there's really three things that they do. Four, but that fourth one, they would have already done it. In the fourth case, the one that they would have already done is their kids take over the business, right? But most of them, their kids already have a career. Their kids don't want to take over the business. So that fourth one is off the plate. What the most common thing they do is when their employees retire, they don't replace them. When their machine tools wear out, they don't replace them. And slowly becomes a room full of old machines, an old guy, and two customers. And the only reason those two customers do business with that old guy is because they always have. And as soon as he retires, the business closes and they go find some new vendors, right? So now we get two options left. They can sell to one of their employees or somebody else that wants to come in and run the business, or they can sell to a large corporation or an investment firm. Those are the two ways that they exit besides just closing. In my experience, when I see them sell to the equity firm, the private equity firm, the people that just come in with money, lasts about 2 years and the business closes. Or lasts about 2 years and then they sell it to another one and then they sell it to another one. So skills that you need in order to help manufacturing would be to be able to come in and help run that business, not just do the programming. How do you run the business? Well, what are the key things? You got to do the sales part, you got to do the management part, but you got to bring in new people, right? Somebody's got to make the parts. The reason I'm so passionate about manufacturing is the people that do the making of the parts, they get about 50% of the new wealth that gets created. So most of 50% of it at least goes to pay the salaries of the people that do the work. They then spend that in their community, helps the community rise up. The whole harbor goes up, right? So skills that you're going to need are going to be, so who's a senior and just about to graduate? It's too late for you guys unless you're going to grad school. But well, you could still do it, right? 1 term left. Go take a business or a management class. Just get some understanding of it. Or there's an excellent book. Don't go take a business class. Get the book by Josh Kaufman called The Personal MBA and read that book, The Personal MBA. And that will give you the skills you need to help, whether you're at a big corporation or one of these small businesses. That'll help you there. But the thing that these businesses need to do, they need to automate. Somebody said that earlier, right? We've got to be able to automate, which means we've got to have engineers that can do that automation and can train people to do the automation. We've got to be able to take people off the street, teach them to be machine tool operators, which means we've got to have engineers that know enough. So you don't have to be the machine tool operator as the engineer, but you've got to know enough about it that you could take Johnny or Sally off the street and teach them in a short amount of time to be useful in the business. Gone are the days. So most of these companies that started 40 years ago, they started by a guy that got trained as an apprentice at one of these giant corporations, at General Motors or at GE or something like that. These companies all had these giant apprenticeship programs, and people learned to be a machinist. Some of them were entrepreneurial. Some of them just stayed there and had their career there. Some of them were entrepreneurial and they went out and started their business, and they hired some more people. And sometimes they hired them from there. Sometimes they hired them off the street. But you've got to be able to build a program where you can train new employees to do these jobs. And we've got to learn to design stuff that's simpler. There's an entire skill set that is gone. And it is the skill set that allowed us to design complex stuff with very simple machinery, right? I mean, we went to the moon pretty much without CNC machine tools, right? CNC machine tools existed. Some of the parts were CNC machined, but we went to the moon pretty much without CNC machine tools. We built the entire country pretty much without CNC machine tools. As we got these machine tools, as these large corporations stopped those training programs and those apprenticeship programs, the skills that they passed on from journeyman, so from master to journeyman to apprentice, they're just disappearing. And there are things that we can't do anymore because nobody knows how to do it. Which means our job as engineers, I mean, we could just, go doomsday prepper. That's a thought, right? We could use our engineering skills to build our doomsday shelters and to buy a lot of weapons and ammunition. I got a really funny story about ammunition, but I won't tell it now. Anyway, but if we as engineers need to design stuff that's simpler to make, it needs to meet the task. It needs to be simpler to make because those skills don't exist anymore for the highly complex parts. So learn something about business. Learn how to train people how to do stuff. So I think our class project this term was great because it was about learning a process you didn't know and then developing materials to teach other people how to do that process. And that is a skill that is going to be very important to you in the future in these small manufacturing companies. Learning how to automate, learning how to sell the idea of automation to your boss, and learning how to sell the idea of automation to your employees or your coworkers. Because when employees at these, especially the smaller companies, hear that you're automating, that you're buying robots, that you're doing these things, they're going to be afraid of losing their job. First thing people do when they're afraid of losing their job, go look for another job. And so you may be automating with the intent of having that person do a more important job, but if they think they're going to lose their job, they leave, and now you're out that employee. So recruiting employees, training them, and bringing in automation systems is what's going to save these small companies that are not closing. And that's what I wanted to talk about today. Any questions? I can do life questions. About half of you raise your hand said you were seniors. I have some life advice for you. Live like a student for as long as you can stand it. Don't go out and buy a new car. Don't go out and get don't buy a house. Oh my God, don't buy a house. Unless you're going to rent it out to people. I do. I've had students that graduated recently, the first year after graduation, they bought a house. Well, you don't need a lot of money to buy a house. You need enough to make a down payment. If you're a first-time home buyer, you can do down payments in the range of like 3% of the value of the house. So you don't need a lot of money to buy a house. The first one I bought, I got a check at the closing because they had already collected the rent for that month, and the amount I still owed at the closing was less than the rent that they had collected. The second one I bought, I financed 100%. Actually, yeah. Other than the one I live in now, every house I bought after that, I financed 100%. So didn't put any money down. But they also were rental properties that would pay the mortgage for me. That's why the math is easy. You want someone else to pay the mortgage. Even when I bought that first house, I still had a roommate in the apartment I lived in for another 6 years. Oh, it sucked. But I had no student debt. I got to retire when I was 27. Live like a student for as long as you can stand it. Anything else? Anybody want to talk about their group projects? So you're going to present. So you've got your written instructions by now, right? That teaches other people how to do this. When you do your presentation, I want you to talk about the technology. So assume that we haven't seen any other presentation that you've done, right? Explain the technology, explain what it's useful for, how it's used, and then step us through the process of doing the steps to get to the finished part. So don't just put up your teaching slides, but step us through the things that we have to do. You can use your slides, your whatever you've put together for your training material. You can step through that on the thing, but take us on a journey of making the part. Yeah.
I would assume that the instructions in the slides would be expected to be less detailed than the actual written instructions, right?
In the presentation?
Yeah.
Yeah, so you could have a lot more detail and text in the written instructions. Yeah. But it's a presentation. It's to convince me and the rest of the class that you learned about the technology and that you're capable of teaching somebody how to do it. But when we walk out of here, we shouldn't expect to be able to just do it. Right? But yeah, it's that that was good enough. Okay. Anything else? Did you guys get a good part? Did you get a good part?
Not yet. We're going to hopefully get it tomorrow.
Anything else? Anybody else? No more life advice? Don't borrow money for anything that doesn't come with a full basement. Never pay more for a car than you can make in a month. I've had some pretty good months, though. Anything else? All right. I had some fun this term. Hope you guys had some fun. I hope somebody learned something. Has anybody seen our TA in the last 2 weeks, 3 weeks? Yeah. Yeah. Probably doesn't watch the videos either.